Okay, so today we're going to be going over lesson 7.6, which is called Hidden Identities, and it's a practice understanding. So whenever we get to these practice ones, that means that you've learned enough, so now that you're in practice mode, okay? So we've built your understanding to a point and developed your understanding to a point where now you can apply that understanding. So we're going to start with the learning focus. It says solve trig equations using identities and graphs. And what mathematical tools do I use to solve trig equations? So we've already been starting solving trig equations for the most part, but now you're going to solidify all of the understanding and all the things that you might feel like are a little bit up in the air in terms of what what you're not sure of and what you're sure of are now going to kind of be brought together in this lesson and then also a couple lessons moving forward. So it says, note, because trig functions are periodic, trig equations often have multiple solutions. Typically, we're only interested in the solutions that lie within a restricted interval, usually within the interval from 0 to 2 pi, like the very first circle rotation. In this task, you should find all solutions to the trig equations that occur in 0 to 2 pi. To sharpen their trig skills, Alice, Javier, and Veronica are trying to learn how to solve trig equations in a math refresher text that they found in an old trunk one of the adults had brought into the archaeological site. Here is how one of them thought about one of the problems. So solve cosine of pi over 2 minus theta equals to half. Alice said, this is Alice. I used the inverse cosine function, Javier. I first used an identity and then an inverse trig function, but it was not the same inverse trig function that Alice used. Veronica said, I graphed y sub 1 equals cosine of pi over 2 minus theta, and y sub 2 is equal to half on my calculator. I seem to have found more solutions. Okay. So using their statements and clues, go back and solve the equations the way that each of their friends did. Okay, so here, let's just go like this. So Alice said she uses the inverse cosine function. So let's do that. So this is going to be Alice, right? So she takes cosine pi over 2 minus theta equals to half. And then so she starts by taking the cosine inverse of both sides. So if this should make sense to you because whenever you take the cosine inverse, sorry, I'm just going to try to scoot this over so I just have to squeeze my cosine inverse in there. If you know if your variable is stuck inside a trig function, you just use the cosine inverse or the sine inverse, whichever one you're using, whichever one you see, and that will undo that. Just like multiplication and division, they're inverses of each other, they undo each other. So same thing goes here. So then what I'm going to do is, what do I have left? I have pi over 2 minus theta equals to whatever cosine inverse of 1/2 is. And some of you are like, oh, I know what that is. I know what cosine inverse half is, Miss Johnson. I know what that is, okay? Because you're familiar with your triangles, hint, hint, nudge, nudge, wink, blink, and you can figure that out. Okay, so the next thing she does, so now she's just solving. She's almost like back in 6th or 7th grade, and she has to solve this. And you're thinking, Miss Johnson, we never solved equations with pi in it. No big deal, but the rules here are still the same. You would subtract pi over 2, subtract pi over 2, right? And so now I'm left with negative theta equals to cosine inverse of 1/2 and then minus that pi over 2, right? And you can plug in anywhere you want, but I have this tendency to plug in last just because, I don't know, that's what I like. The more times you hit enter on a calculator, the bigger your error becomes, kind of thing. So we're going to divide by -1 to every single piece. This is kind of like distributing over division. So then our final answer is theta equals to cosine inverse of 1/2 and that's a negative, and this is plus pi over 2. So I'm going to plug this into my calculator and see what I get. So I get negative cosine inverse of 1/2, oops, not 1/5, 1/2, and then plus pi over 2. Actually, I'm not going to do plus pi over 2. I'm just going to leave it like that. And so it gives me this funny answer here. So I'm going to hit degrees and see if it's a negative 60. So I'm going to say that this is negative 60 degrees here, right here. And then it says plus pi over 2. So this is like talking about things in hours and seconds. So you want to keep your units the same. Some of you did recognize that this cosine inverse of 1/2 was your 30, 60, 90. If you didn't recognize that, just know that whenever you have a 1 and a 2, you could check to see if you are in your if you're in your 30, 60, 90 or your 45, 45, 90. So this is cosine, so we want to know what this angle is, and that's your 60 degrees, right? Johnson, why did they give us the answer of negative 60 degrees? Because this was negative right here. So they were asking for the opposite of that. So here, we got our answer. Hold on a second. Okay, so now we're looking at negative pi over 3. Does that make sense? Because we're just taking the opposite of, so pretend that this guy right here, this guy right here, you just hold on to him, do him last. So cosine inverse of 1/2 would be 60 degrees. And so you're just bringing that negative down. So then I converted it to radians, and now I'm going to add it to pi over 2. So if you remember your fractions, this is just negative. I'm going to use denominator of 6, so 2 pi over 6 plus 3 pi over 6 is pi over 6. So this is what Alice gets as her answer. Okay. All right. So then the next part says, Javier says, I first used an identity and then an inverse trig function, but it was not the same inverse trig function as Alice used. So we got to go find this identity right here. So I'm going to go to our identities page, which is over here. And I'm looking for cosine of pi over 2. And for cosine of pi over 2, there it is. Cosine of pi over 2 minus theta is sine. Okay, so it's sine. So I need to write that. I'm going to write that identity down so you know where I'm coming from. So this is now Javier's. Where am I going to go here? So we will write Javier's up here. So Javier's solution looks like this, right? So starting again, same problem, cosine of pi over 2 minus theta equals 1/2. Javier uses this identity. Sorry, keep changing my size here. Okay, so he uses this identity, and the identity is cosine of pi over 2 minus theta equals to sine theta. So you can think about this as substitution, right? Instead of bacon on my sandwich, can you please put avocado instead? Right? Can you please put avocado instead? That's what they're asking. Okay, so I'm going to put sine of theta here. So I'm going to write, so this is now sine of theta equals to 1/2. You see how that happened? So we were just exchanging stuff. So this is how you would use identities to solve equations. So whenever you see anything that you're like, oh, I saw that on the identity page, and we've kind of used it and improved it, then we can now use it. So here's sine of theta equals to 1/2. Now, some of you are like, oh, Ms. Johnson, I know what triangle this is. This has got to be my 30, 60, 90. And you're like, oh, here, this is Javier doesn't know about this. I need to teach him. So here is 1 over 2, and we're looking at this angle here. So that's my 30-degree angle, or my pi over 6. So you're like, oh, theta equals, well, let me put it over here. So theta equals pi over 6. Okay. No worries. Actually, Javier doesn't see this because it says over here, Javier, what does he do? And then uses an inverse trig function, right? And then uses an inverse trig function. So he's going to take the inverse trig of both sides of here. So he's going to take sine inverse of sine and sine inverse of 1/2, right? These will cancel. So I'm left with theta equals to sine inverse of 1/2, which again on the calculator, if I go sine inverse of 1/2, I get 30 degrees, which is pi over 6. So theta equals to pi over 6. So he gets the same answer that she gets, right? Javier gets the same thing as Alice. Notice Javier said, but it wasn't the same inverse trig function that Alice used. And they use different inverse trig functions. Javier uses sine inverse versus Alice uses cosine inverse, right? Okay. Last but not least, Veronica said, I graphed. Okay, so we're just going to go straight graphing. She graphs cosine of pi over 2 minus theta minus x. And she goes, y2 is equal to 1/2. So I got to write y equals 1 divided by 2. Okay, and then I got to change this to radians just so it, okay, there it's showing up. And so she says, I seem to have found way more solutions. So the solutions here are going to be all the places where these two lines meet up. So there's our answer, pi over 6 right there. You see it? But our answers are also 5 pi over 6 and 13 pi over 6 and 17 pi over 6. Okay, so we did all of them. Okay. So we did that. So it says, how does Veronica's solutions match up with Alice's and Javier's? And we talked about that. And then what might be different? Well, Veronica finds a bunch of solutions versus Javier and Alice only find one. Okay, only find one. So it says, solve each of the following trig equations by adapting Alice's and Javier's strategy. That is, you may want to see if the equation can be revised using one of the trig identities you learned in the previous task. And once you've isolated a trig function on one side of the equation, you can undo that trig function by taking the inverse trig on both sides of the equation. Once you have a solution, you may want to check to see if you have found all possible solutions on the interval for the first rotation, 0 to 2 pi, by using a graph using Veronica's strategy. Okay, so we're going to solve it using either Alice's or Javier's way. And then we are going to check to see if there's any more in that interval. Now, if you look at Veronica's, 17 pi over 6 is outside that 2 pi, 13 pi over 6 is outside that 2 pi. So your two answers in this case from 0 to 2 pi, your first, from 0 to 2 pi is going to be pi over 6 and 5 pi over 6. Okay. All right. So then it says, so here's sine, so you get to choose if you want to use Javier's way by bringing in identities first, or if you want to use Alice's way by going after that going after the inverse first. Okay, and some of these you will have to use something first, and then some of you won't, right? So this one, the first one, number 3, you could use either one. Either one is okay. There is an identity that does talk about sine of negative theta. But if you like taking that sine inverse first, go ahead. You will still get the right answer, right? So I'll do sine inverse first. So I'm just going to take my equation and write sine of negative theta equals to, and I'm going to leave a little space so I can squeeze in my my inverse sine here. So I'm going to go sine inverse on both sides. And when you do this, notice those two, they inverse each other out. So all I'm left with is negative theta equals to sine inverse of negative half. And some of you are like, Miss Johnson, I know that triangle. It's a negative 1/2. I know what that is. Very good. Very good. Okay, the last thing is I'm just going to divide out by this negative 1 here. So my answer equals to, and you'll notice that I'll always write like equals to and then about. So theta equals to negative sine inverse of negative 1/2. And so some of you are like, oh, Miss Johnson, I know what that is, right? So you can use it. Oh, you know what? You can use a calculator. Actually, I'll show you first. So when I'm thinking about this, I'm thinking about my unit circle and graphing these, and I'm looking for where this is. So you should already know that you're in 30, 60, 90 triangle specifically because you have this triangle here and its opposite is 1 and its hypotenuse is 2. You're in the land of 30 degrees or you're in pi over 6. Oops, sorry, pi over 6. Okay. So I'm looking for where sine is equal to negative 1/2. And that's down here because the sine is your y. So your two triangles are going to look like this, negative 1/2 and negative 1/2. And if this doesn't make sense, don't worry. You can use your calculator. I just kind of like to give you guys pictures of what you're actually looking at. So this part here, sine inverse of negative 1/2, that equals to these two angles here and here. And then it says, then you would have to multiply by a negative. Okay. So with that being said, let's go find your calculator. So this is going to be negative sine inverse of negative 1/2. And it gives me, I'm going to go back to degree mode. It gives me 30 degrees. So it gives me 30 degrees. Okay. So theta equals to 30 degrees or pi over 6. But again, they told you to graph it using Veronica's way just to make sure you're okay. So you're going to go back to your original equation and you're going to graph this on one line and this on another. So here goes this. So y equals 2, and I'm just going to use this again, negative 1/2. And this is going to be sine of negative x. And then change this back to radians so we can actually see it. And we're going to be looking at the very first from 0 to 2 pi. So I'm going to click on these and try to get all the answers. So those two answers, pi over 6 and 5 pi over 6. And this one is 13 pi over 6. So his answer is off. So our answers are going to be pi over 6 and 5 pi over 6. Pi over 6 and 5 pi over 6 because of the graph. Okay, so here's my answers. Okay. Now, if some of you are wondering, okay, Ms. Johnson, what were you going to do here with this thing? So because our answers were these two answers here, and then you took the negatives of those, right? The negatives of those is actually these two, right? So this would be 7 pi. Let me see. This guy would be 7 pi over 6. But then the negative of 7 pi over 6, you start here, and you would go and end here. Same thing goes with this other guy. This guy would be 11 pi over 6. And if you graphed him, you would start here and go all the way to here. So we did still find the same answers. You can check your answers again by plugging in here. That's always a good thing. So you go sine of negative, and our answers were 5 pi over 6. And see how you have your answer as -1/2. So we're good, right? We're good. We checked our answers several different ways. Okay. For this one, you can't take the sine inverse, cosine inverse, or tangent inverse because we have two of them together. So the very first thing that I'm going to keep telling you to do is when you get stuck like this, one of my first strategies is turn everybody into sine and cosine. Turn everybody into sine and cosine. Okay. So I remember that one of my identities here is tangent theta equals to sine over cosine. Okay. So I'm going to rewrite this using this identity. So it says cosine theta times, now instead of writing tan, I'm going to write this guy here. Sine theta, cosine theta. And then I'm just going to copy whatever I see on the right-hand side, which in this case, is root 3 over 2. Do you see anything that could happen there? Does anybody see anything that can happen right there? And some of you are like, yeah, Ms. Johnson, those cosines, they divide out. Exactly. These cosines divide out, and now I'm left with sine theta equals to root 3 over 2. Now, if you want to do this using the graph way, like I'm encouraging some of you to do, so which triangle are you in? That's the first question I'm going to ask you. Which triangle are you in? And you're like, I'm in the 30, 60, 90. Very good. So this guy is my opposite. So my 30, 60, 90, let me just draw a picture over here. Right? This is 1, 2, root 3. So we're actually looking at this angle here. So that's the pi over 3. That's the 60 degree or pi over 3. So the theta that we're looking at is pi over 3. So theta is pi over 3. And the way you get your second angle in that first circle, so here's my first one, right? So this is root 3 over 2. Is there another right triangle that you can draw that has the opposite side also being root 3? And you're like, yeah, Ms. Johnson, if you reflect it this way, this is also root 3 over 2. And I'm like, yeah, that's right. Another way you can come up with that second one is by using that acronym that we were talking about. All students take calculus. Because we're in sine, we're looking for where else is sine positive. So that's in all and in students, which is all of them and sine. So it's basically these two angles. So I already found pi over 3. What's this angle here? Well, because I'm in the land of pi, I know this is 3 pi over 3, and I took away a slice of pizza. Does everybody see how I took away a slice of pizza? Here's my pizza. Right? Maybe my pizza looks like this. See my little pizza wedge there? So instead of having 3 pi over 3, I now have 2 pi over 3. And there's my two answers. Okay. Now, some of you want to do the sine inverse on this guy. Let's show you that just to make sure. So you had sine theta equals to root 3 over 2, and you wanted to sine inverse. So you would have gotten theta equals to the sine inverse of root 3 over 2. And then we bring our calculator in. Root 3 over, we don't want the over 2 under the radical. So I'm going to scoot in that way, over 2. There you go. So we get that, but in degree mode, it's 60 degrees, which is exactly what we got over here, right? This guy here is 60 degrees. Those are the same. And then the last little way, just making sure that we check using Veronica's way of graphing both things. We would go like this. We would go cosine tangent. So we go cosine, where am I? cosine x times tangent x, and this is equal to root 3 over 2. So this is going to be square root of 3 over 2, but that's not it. And then we want to go back into radians, right? So now if you look, where's my home? There it is. If you look, my first answer is pi over 3, and my second answer is 2 pi over 3. And that's exactly what we got right here, right? Okay, so this is the one that I want you to try by yourself. It's sine 2 theta equals to root 2 over 2. Sine 2 theta equals to root 2 over 2. You should know the triangle that we're in. If you don't know, that's okay. So go ahead and try that and then come back to me and we will finish, and that's where we'll finish. All right, now that you're back, we're going to solve sine of 2 theta equals to root 2 over 2, right? And some of you already see this as, oh, this is a 45, 45, 90 triangle because of that root 2. You're exactly right. Okay, and so you'll see this as this kind of like this. And then this is root 2, and this is 2 opposite. This is my opposite, and this is my hypotenuse kind of thing. And then, so on the x and y axes, right, where else is sine positive? And you're like, oh, the second triangle is going to be here, Miss Johnson. Very good. Okay, so we are in the land of pi over 4. So this guy here, which now it says 2 theta, not just theta. So be very careful there. So 2 theta equals to pi over 4. And 2 theta equals to this angle here, which if you were in the land of pi over 4, this is 4 pi over 4. And then again, I took away a pizza slice or a piece of pi. So that would be 3 pi over 4 because I'm missing one, right? 3 pi over 4. And then you're just going to solve. You're going to divide by 2, and then that's going to be your answer on each side. Divide by 2, divide by 2. And so we get pi over 8. And I have a feeling we're going to have more answers. So 3 pi over 8. Okay. Okay. And the reason why I say we're going to have more answers is because our denominator is like we've now sliced our pizza up even more. So when we check over here with Veronica, which is a really good check, right? When we write sine of 2x equals to root 2 over 2, we get pi over 8, which is what we got, 3 pi over 8, which is what we got. 9 pi over 8 is still in the first rotation. So this is what I was talking about. Ms. Johnson, where would we get 9 pi over 8? Well, that I will explain as we go. For now, I'm just going to keep you right here. Just keep using your Veronica strategy so that we can, that is outside of 2 pi. So I'm going to write my other ones down, 11 pi over 8 and 9 pi over 8. So these ones I'll write in a different color. For those of you who want to know where that comes from, I'll ask a question and then I'll leave it hanging so that we can talk about it a little bit more later. So is this, if you look at this angle here, right here, and we called this pi over 4, right? Is that his only name? Is that pi over 4's only name? And some of you are like, no, we could add exactly. So stay tuned for the next video because we're going to talk about that as well. Just so that you can learn how to find all the solutions in the very first rotation. Okay. And you will get better at this to the point where you're going to be like, oh, I bet you there's going to be more answers than those two that we normally get because blah 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 blah. Okay. Thank you so much for listening. I hope you have a great day.